I'm here with a new video for the Halliday Resnick Walker Fundamentals of Physics, chapter number 25, and it is problem number 29. The question is, assume that a stationary electron is a point of charge. हमने assume करना है, we have to assume a stationary electron as a point charge. So we'll use the formulas for the point charge as we found in the chapter number 21 and 22. What is the energy density of its electric field at radial distances r is equal to A part है 1.0 millimeter, B is 1.0 micrometer, C is 1 nanometer, D is 1 picometer, and E is what is the energy density if the R what is U, what is this U, U mean the energy density is denoted by U, small u, in the limit R tends to 0. When R tends to 0, then what will be the energy density? So let's solve it. The given data is we have to know that charge on electron is 1.6 × 10⁻⁹ coulomb, and for part A, R is 1 millimeter. Millimeter is power -3, so R is equal to 1 × 10⁻³ meters. We have to find the energy density. First, we find the electric field strength at the distance of radius of 1 millimeter. We will treat electron as a point charge, so E will be equal to 1/4πε0 into Q over R square. This is the formula for the electric field due to a point charge, this formula. Okay, so E will be equal to, plug in the values, 1/4πε0 is 9 × 10⁻⁹ Newton meter square per coulomb square, and Q is 1.6 × 10⁻⁹ coulomb. R is 1 × 10⁻³ meter square. It is square, so we will put square. When simplify it, and units are simplified to units per coulomb, and we get E is equal to 1.44 × 10⁻³ Newton per coulomb. This is the electric field strength at a radial distance of 1 millimeter. So we now find the energy density at this distance. We know that the formula for energy density is U is equal to half epsilon0 E square. We know E, put this value of E here. This value of E will be, this value will be plugged here. So we'll get U is equal to 1 over 2, epsilon0 is 8.85 × 10⁻12, and E is 1.44 × 10⁻³ we just calculated. So just simplify it. The unit will be joule per meter cube because the energy density is joule per meter cube. So when you simplify it, answer comes out to be now 9.16 × 10⁻18 joule per meter cube. So this is the energy density at 1 millimeter distance, radial distance, for the electron treated as a stationary point charges. B part is if the R is 1 micrometer, then we will have same data, only R will be changed in the other data. So here it was 10⁻³ instead of as in part A, now it will be 10⁻³ so we will 10⁻6 is micro, so we will simplify it, and E comes out to be 1.44 × 10⁻³ Newton per coulomb. हमने वही कुछ करना है, सिर्फ हमने यहाँ पर वैल्यू जो है माइक्रो के लिए 10⁻6 कर देने, वही सेम पार्ट ए की तरह. सो वी विल गेट U is equal to 1 over 2 epsilon0 E square. Now E is 10 power, now E is changed, now E is 1.44 in terms of +3. So only power is will change and the numbers are same. So when we simplify it, it comes out to be 9.16 × 10⁻⁶ joule per meter cube. So that is the energy density at a distance of 1 micrometer. Similarly, next part is C part is, and we have to find the energy density at the 1 nanometer. Nanometer means 10⁻⁹. So wherever it is 10⁻³ or 6, we will replace it with 10⁻⁹, and same calculation, and the answer will be 1.5. E will be 1.44 newtons per 9 Newton per coulomb. Now electric field strength has increased because distance has decreased. Therefore, the energy density has to increase as equal to 1 or 2 epsilon naught E square. We put it value, plug this value, we plug in this value in the formula, and we get the energy density at a distance of 1 nanometer as 9.16 into 10 power 6 joule per meter cube. Okay. Next is so in part D, if the distance is 1 picometer, pico means 10 raised to power minus 12. Therefore, we will use minus 12 here. When we put R here, R is 1.10 to minus 12. So E comes out to be, in this case, 1.44 into 10 power 15 Newton per coulomb. So we plug in this value in the formula for the energy density to get energy density as 1 over 2 epsilon naught E square. So put the value, this value here, and this value will be plugged in here. This value is plugged in here. So now the U comes out to be, this is 15, sorry, this should be 15. This should be 15. So answer comes out to be 9.16 into 10 raised power 18 joule per meter cube. So the energy density at a distance of 1 picometer will be 9.16 into 10 raised power 18 joule per meter cube. So this is 15. Please correct it. This is 15. So next E part is when the R tends to 0. So when R tends to 0, it is quite obvious that when R tends to 0, in this formula here, R is 0 in the denominator, 0 in the denominator means infinity. So electric field will become infinite, therefore the energy density will also tends to infinity. So that's the solution of the problem number 29. Hope you like it. If you have any query, you can ask me in the comments. I will respond to it, inshallah. See you next column, next video very soon. Until then, Allah Hafiz. Take care. Bye bye.